All right, let's get this party started. Hello, everybody. Basil. Woo! Gonna start with something incredibly dangerous. I'm going to do some live coding. So, let's start by loading the same dataset in 3 different versions. A pandas data frame, a polars data frame, and a polars lazy data frame. For anyone not familiar with the best dataset in the world, it's just 3 flowers and a few descriptive statistics about them, nothing particularly groundbreaking. We also have a task, which doesn't look particularly groundbreaking. We just need to write a function, which will first filter out setosa flowers, we just don't like them. And then, for each remaining column, we need to normalize it and add a new column with the normalized value. That is to say, subtract the mean, divide by the standard deviation, and insert it. Sounds very simple, but there's a catch. The function should work with a pandas data frame, a polars data frame, and, for extra bonus points, a polars lazy frame. Let's see if we can do this. So first solution would be to just convert everything to pandas, write pandas code, which we're familiar with, reset the index because I don't like it, sorry James Powell, and then restore the original data type. This is fine if you're working with relatively small data on CPU, but repeatedly converting large amounts of data from GPU to CPU is going to be expensive, so maybe not the most generic solution we could find. Which brings me to the imaginatively named second solution, solution 2, which involves 2 if-then statements. Well, 1. We have 1 branch for polars and 1 branch for pandas. Doesn't look too bad, but quickly becomes a maintenance nightmare. So let's go on to the super secret solution number 3. Let's see if we can do better. Let's write this without any if-then statements and without any data conversion. I'm going to start by calling a super secret magic life-changing pro method which the world has never seen before until now. You were the first people in the world to see this. World premiere. Imagine, if you will, that you're experiencing the Beatles performing Hey Jude for the first time. Yeah, hope I didn't set the expectations too high with that one. So you're going to write DataFrame Consortium Standard, and this teleports you into a parallel universe in which things just work a bit more simply, a bit more predictably, and a bit more consistently. Right, the first thing we're going to want to do, we're going to want to make a mask to filter out these pesky setosa flowers. So mask df.get column by name, not the most ergonomic, but it does what it says on the tin. So species is different from setosa, easy enough. Then we're going to filter based on this mask. df equals df.getRows by mask. And then finally, for each column, we're going to want to make a scaled value. So I'm going to copy the pandas code because it's not completely far off. So going to rename column to column name for maximum explicitness. Going to rename columns to get column names because that's just what's available in the parallel universe which I entered by calling this a super secret life-changing pro magic method. Then, if column name is equal to species, I'm going to continue. We are not finding the mean or the standard deviation of strings just yet. And then we need to create a new column, which I'm going to call new column. And this one, I'm going to start by getting the column given by column name. So df equals, so new column equals df.get column by name, column name. And then let's standardize it. Woo! New column equals new column minus new column dot mean divided by new column dot standard deviation. And then we need to insert this into our data frame. So df equals df.insert. I'm going to insert it at the end. So len df get column names. Yeah, I could have stored this in the variable, but when is getting that ever the bottleneck of anything? Then the name of the column is gonna be column name. It's so much harder to type live. Please bear with me. Not sure how live streamers do it. Right, column name underscore scaled, and then let's insert the new column and delete this line. And then finally, because we were just working in a parallel universe, which we entered with this super secret pro magic method, we need to bring things back down to earth. And we do this with the df.bringThingsBackDownToEarth method. I am, of course, messing with you. It's just df.DataFrame. They didn't accept my suggestion, so this is what we're stuck with. Right, I'm just going to read through this once again because live coding is scary. df, so first we entered our parallel universe. Then we got the species column by name and checked when it's not equal to setosa. We then filtered rows based on that mask. And then for each column name, we skip the column species. We then make a new column. We subtract the mean and divide by the standard deviation. And then we insert that at the end. We suffix underscore scaled. Looks legit. All right, gonna run this. And now for the real test. Let's see if this works with pandas. All right. Let's see if it works in exactly the same way with a Polar's data frame. Woo! And the real proof in the pudding is if it works with a Polar's lazy data frame. Now, you're not going to see the numbers here because this is lazy, but if we call .collect, then there you go. There's your Polar's lazy data frame. Oh, thank you. Was not expecting that, but I welcome it. So hello everybody, I'm going to be talking to you about DataFrame-agnostic code. I shall now introduce myself, not because I didn't rehearse this, but because I like doing things in a different order. Hello, my name is Marco. I work at Quantsite Labs as a software engineer. I'm also on the Pandas core dev team, and for a few months I've been a volunteer helping out with Polars as a volunteer. Huge fan of both projects, and I'm really interested in bridging the gap between these as well as between other data frames. So, first of all, why would anybody care about DataFrame-agnostic code? Let's talk about that, but first, let's talk about what we're going to do. So we just did very dangerous live coding, which we survived, winning. Now I'm going to give you a bit of context and scope. We'll then talk about where we go from here. We can then have X seconds of engaging Q&A and 5 minutes minus X seconds of awkward silence. It's really up to you how long the X is going to last. So why would anybody want this? Yeah, there have been a bunch of protests about libraries only supporting pandas data frames, and before these protests get violent, we need to do something about it. The easiest way to do something about it would be to just convert everything to pandas. Does that work? Well, it depends. Smallish data on CPU? Be my friend. Largish data on GPU? Yeah, maybe not. So why can't everybody just copy the pandas API? Well, it's a bit big, it's a bit flexible, and as you just saw in the previous presentation, sometimes it changes. Furthermore, it's already been tried, and the user experience is mixed, which is why authors of libraries which try to mimic the pandas API are very interested in having some standardized API, which they can then implement in a way such that this guy will not say, "Thou shalt not pass," to accelerated operations. I've not seen that movie, so I hope the reference makes sense. Can you use this already? Yes! This was merged into pandas last week and Polars the week before that, so thanks for doing that just in time for my talk. Glad I could give a live demo. Modin QDF and other libraries are also looking at implementing it. But what's inside? What's inside the box? Yeah, that's another movie I've not seen. But if you want to implement this yourself, you just need to implement some standard aggregations, comparisons, filtering, selection, sorting, group by, common data types, conversion to and from arrays. We're not going to do all of the more esoteric, let's put it this way, functions that you might find in pandas. In particular, no index, no multi-index. Sorry again, James Powell. It's maximally explicit. And what comes next? So first of all, I'm in contact with some scikit-learn devs. Could we get it to work in scikit-learn? Maybe yes, maybe not, but the process is going to teach us a lot about how valuable this is and how far it can get us. We need to set clearer expectations for lazy engines. So the Polar's lazy frame worked in the live demo I did because I practiced it, but in general, people might be caused by surprise when they find things maybe don't work exactly the same way for eager and lazy engines. Just can't get everything to work in the same way, but the documentation should be clear about what people's expectations can be so that they can truly write DataFrame-agnostic code. And then finally, we need greater support for different data types, like categoricals and date times. Really excited about that first one, because I really like putting time zones on things. So in confusion, what did we talk about today? So first of all, how to write DataFrame-agnostic code. So step one, you call this super secret, life-changing pro-magic method df.dunder DataFrame Consortium Standard. This transports you into a parallel universe where you've got the DataFrame API methods available to you, and as long as you stick to them, then step 3, congratulations, you have written DataFrame-agnostic code. Who could use this? Libraries where maybe it's just too expensive to repeatedly convert to and from pandas. I'm thinking about machine learning, feature engineering, and maybe one of you. Who implements this? So it's in the pandas 2.1 RC, in the Polar's greater than 0.18.13, and I'm in contact with people from Modin, QDF, and ONNX, and so more DataFrame libraries implementing the standard are going to come. Basil, you've been absolutely fantastic. Have a great day. I've been Marco. Any questions? Okay, Luca. It's always fun when you recognize people from the audience, especially other Italians.
Ciao, Marco.
Ciao.
You wrote in your live demo a for loop, creating new columns, and specifically for the Polar case, I suppose, I guess, I feel like it's very likely that when you would modify more than a column at once, every new creation of a column is dispatched to a different thread in your kernel or something, or in your process or something like that. Bottom line is, how could you preserve in such operation the degree of parallelization while still using the DataFrame Consortium Standard methods? Thank you.
That's a great question, and I think this is going to be implementation specific, so you might not want to rely on this in general. Cool. Any other questions from other Italians in the audience? Non-Italians are also welcome, just don't get precedence. Okay, over there.
Hello, thanks for the talk. I just wanted to know, how was the process of the standardization? Because it's usually quite hard to bring people from different projects on a table and agree something.
Yeah, that's why it's been taking so long. The number of fights I've been getting into about this have been taking a toll, but we're getting there. And perhaps part of the reason is that we've got a separate package which implements the compatibility layer. So none of these libraries need to change their main API namespace. It's going to be virtually impossible to get everyone to agree on what their main namespace should be. But if everyone just implements these functions in a separate namespace, well, this is not a user-facing thing. It's just for developers who might be interested in DataFrame-agnostic code. So it's a bit easier to agree on things then. Nonetheless, agreeing on the specifics about how to handle lazy engines is proving a little bit challenging, but we'll get there.
Thank you.
Thank you. Okay, question from Richie.
Very cool that you made the lazy engine work. Can you show the query plan? I'm curious, and to do some reverse engineering.
All right.
What you're producing here. Right. Yeah. So I think Luca's point is valid, that we lose the parallelization. Yeah.
Yeah, that is true. And yeah, maybe we need some API as part of the standard that would allow this to be done in parallel, if possible, and it won't happen for libraries that don't do it.
Yeah, I think it would be possible, but you would need to check if the next expression is dependent on the previous one. But cool stuff, definitely.
Cheers, thank you. And yeah, for anyone not familiar with the Asker, that's Richie, creator of Polars. Go to his live talk, his keynote talk tomorrow. It's going to be awesome.
Any more questions? No, so thank you very much for showing us this life-changing super pro magic function. Applause, please.
Oh, thank you. And yeah, hope you all have a nice lunch.